Okay, class, Assalamualaikum and very good afternoon. Again, we meet in the uh, virtual class. I need to record the video for our lab and also the lecture. So today is lab 7. We talk about discover relationship. Yeah? So we already discussed about the relationship. Relationship got four types. So first is association, aggregation, composition, and inheritance. Yeah. So uh, when you model your object, so you need to relate, yeah, which object communicate to other objects, and the question is how you want to discover the relationship. Yeah. So in this video, I will show you uh, the process, how to define and represent relationship on sequence diagram and define and represent the relationship on class diagram. So remember that the object class is discovered during the use case analysis. So, so there is a continuation from one process to another process. So, so this involves a very comprehensive solid element life cycle. So object-oriented system analysis and design. So it's very important for you to understand the process. Yeah. So start beginning from the use case definition. Yeah. Before use case definition, you need to define the user requirement. Okay. So you construct the decomposition, to define the module of your system, module or subsystem. Yeah. Don't be confused. And when we talk about module is and submodule, it's actually system and subsystem. Okay. And then after you come out the use case, you need to describe the or you need to construct the use case specification, right? So the objective of use case specification is to discover the object class, yeah, by looking the stereotype of the object. So once you discover the object class, then you represent the object on the class diagram, and you model it. Uh, you model the object behavior to sequence diagram. Okay, I show you in the class in the star UML. So this is a basic class diagram. Yeah. Okay. Okay. So let's say you from the beginning of the object modeling. So this is a basic uh, class diagram, a basic class or object you discover. Okay. So and then you don't know which object relate to another object. So what you need to do is you you model the object class behavior using the sequence diagram. Okay, you can start from beginning. Okay, you give an example. You create a new diagram, for example, sequence diagram. Yeah, and then you create the sequence diagram. So I'll give you example. This one. Okay, we have a system. Oh, come on, where is it? Oh yeah, yeah. Okay, this example of emit screen. Okay, and then we diagram it. Okay. So I think it's better you name your class diagram first. And when you got a lot of class diagram without name, so it's very difficult to manage it. So the class diagram for admit patient, uh, lab 7. Okay, and then this is a sequence diagram for admit. Sequence diagram, name it, yeah, for admit patient lab 7. So easy to remember, okay. uh, then you start to create your lifeline. Okay, the system, for example, then admit screen and patient DB, yeah. Admit screen, patient DB. Okay, so normally start with the admit screen, right? And then you pass the system, you pass the information to the uh, controller, yeah. So you can delete this one. Okay, start model it, and of course who do this process, who do the process of emit screen. So of course the registrar, right? Registrar. Okay, so you can mark, give a stereotype for this registrar as an actor, okay. Right. Actor registrar, yeah. Okay, so registrar uh, will use the open the screen, and then when they enter the information, they will submit to the system, and the system receive the message, input, and pass to the patient database. So you choose the relationship, yeah, like I told you just now. The relationship got four type, yeah. uh, Whether association or relation, composition, and inheritance. So that relationship can be done, can be designed when you construct your class diagram. Okay. So now what we need to do is we just to relate, yeah. We just to connect the object to another object to show their relationships. Okay. So the message from the registrar is normally go to the screen. Okay. And then from the screen, emit screen is submit to the system. From the system will connect to the patient database to add or update or delete the record. Okay, so what is the message normally registrar enter? Okay, so normally they enter, okay, enter input. Right. Okay, what are the input? Be patient ID and patient name. Okay. Okay, now you already create the relationship between registrar and admit screen. But in sequence diagram, we call it message. Yeah? So this is how you relate the register object to the admit screen object. And then after you enter the admit screen, you submit the information, right? You submit input. Okay, what is the value carried by the submit input? Of course, the patient ID. So the message is sent to the system, and system process and submit the information. Maybe submit input for verification. Submit for verification. Okay. What are the value the message bring? Is a PID and also the uh, input. Okay. And then when the message is sent to the patient database, so what are normally this object do, or this function do? So they will check the input. So verify patient. Right. Then after verify is complete, then it will add patient. Yeah. I don't know why the latest version of Star UML is very difficult to use. Last time is very easy to use. Let's see. Okay, never mind. And then when the patient record successfully added into the database, then the message will give to the patient. Sorry, I think this version got a lot of constraint. They got a lot of features, but they're very difficult to. Some of the previous features is not in the new version. Okay, so you send a message to the patient. Message. Yeah. Uh, course message. Message value. Yeah. Okay, finish. So this is how you define and represent the relationship on your sequence diagram. Okay, so where you get this information, this sequence of flow, is from your use case description. Yeah, use case specification. Okay, uh, and then after you got this sequence diagram, after you model the dynamic behavior of the objects. When you go to the class diagram, you start to update your class diagram by putting the relationship, whether the relationship is association or aggregation or inheritance. Okay, then you go here. uh, so you start with the registrar, right? Registrar. So this registrar is a actor. Okay, you can define this as a stereotype here, and very easy to identify the stereotype. Okay, okay, start to create the relationship on your class diagram. So based on the sequence diagram. So registrar to emit screen to get to the system to question DB. Okay, go to the class diagram and then you start to associate it. So start with the relationship with association, because association is very simple relationship. Okay, so after you refine your class diagram a few times, then you can identify uh, which object class can be used, the composition or aggregation, or use the generalization. Okay, start with the association first, and then you go to the admin screen, pass a message to the system, and then the system pass message to the database. Okay, so this is a uh, basic class diagram. How you create the relationship on your class diagram. Okay, let's say your patient DB, you want to generalize your patient DB. Yeah, so patient DB is a type of person. Okay, so you can create one class, for example, patient, a person. Okay, then you can all the attribute and operation of person actually can be inherited by the patient DB. Yeah, or let's say you got another uh, this is patient DB, maybe is a health worker DB, for example. Yeah, health health worker is a staff, yeah, including doctor, staff, nurse, medical assistant, tea lady, driver, and so on. So that relate to the healthcare provider, who work with the healthcare provider. So we call it health worker DB. So health worker information is actually is part of the person. Yeah. Health worker is a person. Patient DB also a person. So some of the attributes can be generalized. Yeah, can be generalized and shared by the health worker and patient DB. So we can create the. That's why I told you their presentation of the latest version of Star YAML is not user friendly. So we generalize the patient DB to the person. Okay, and health worker can inherit the person information. So this become uh, inheritance type of relationship. Yeah. So some of the information of the person can be inherited by the health worker or patient. Okay. So this is a way how you create your relationship. You define and represent the relationship on the class diagram. Okay. So this is how you define and represent your relationship on sequence diagram. Okay, by design or by uh, construct the message between object. Okay, class. I think that's how uh, lab 7. So what you need to do is each of your use case. So you need to model it, dynamically. Yeah, you model the object behavior of your uh, each of the use case, and then after you discover a new object or new class, so you need to update your class diagram. So this is an example. Yeah, maybe after you refine and you review your requirements, so you get a new requirement where you can create another uh, class which is can inherit from the patient DB and health worker. Okay, this is subject to your design decision. Yeah, whether you want to implement the type of relationship uh, of inheritance or generalization, or you can use a very simple relationship like association. Okay, class. So what you need to do when you update your class diagram, so please update your document. Yeah, go back to your main document, example this one, then update your class diagram. Okay, copy and paste. Okay, uh, that's it for the lab 7. Then we continue to lab 8, how to discover the operation and attribute. Okay, thank you very much and assalamualaikum.